In this video, we're going to talk about equations and graphs. We're going to begin with a definition. An ordered pair x comma y is called a solution of an equation that involves x and y if, when the first coordinate is substituted for x and the second for y, the resulting equation is true. Now, as an example, the ordered pair 2 comma 5 is a solution of the equation 6x plus 4y equals 32, because when you plug in 2 for x and 5 for y, you get a true statement. 12 plus 20 does equal 32. Now, are there other solutions to the above equation? Now, the answer is yes. In fact, maybe you want to pause the video right now and see if you can come up with a few other solutions on your own. One of the solutions is the ordered pair 4 comma 2. If you plug in 4 for x and 2 for y, you get 24 plus 8 equals 32, and that's a true statement. Another ordered pair would be, another solution would be 0 comma 8. And yet another one would be 6 comma minus 1. Okay, you'd have 36 plus minus 4 does equal 32. In fact, there are actually infinitely many solutions of the above equation. Now, let's plot these ordered pairs that we found in a Cartesian coordinate system. Okay, so let's plot the solutions that we found. Now, the first one that we found up here, remember, was 2 comma 5. So let's plot the ordered pair 2 comma 5. Okay, it's right here. The ordered pair, let's put it in here. The ordered pair 4 comma 2 is right here. 0 comma 8 is up here. It's along the y-axis. And 6 comma minus 1 is down here. Okay, 6 minus 1. Now notice that all of these points lie along the same straight line. Okay, they all lie along the same straight line. In fact, all of the ordered pairs along this line are going to be solutions of that equation. And really, there are infinitely many ordered pairs along this line. They're all solutions of this equation. Okay, this line is what's called the graph of that equation. So let's define graph. The graph of an equation in two variables is the set of points, or ordered pairs, in the plane whose coordinates are solutions of the equation. Okay, let's look at another example. What does the graph of x squared plus y squared equals 25 look like? So what we want to do is find all of the ordered pairs that make this true. Now, one ordered pair that makes it true is 5 comma 0. If x is 5, y is 0, that's true. Another one is 0 comma 5. Okay, yet another one would be minus 5 comma 0, because if you take minus 5 squared, you get positive 25, and plus 0 squared would equal 25. A fourth point would be 0 comma minus 5. Now notice we can plot these points. The point 5 comma 0 is right here. 0 comma 5 is along the y-axis. Negative 5 comma 0 would be over here. And 0 comma negative 5 is down there. Okay, now what does the graph look like? Well, it's hard to say right now. Maybe the graph could be a diamond, for example, or maybe it could be a box, like a square, or maybe it could be a circle. In fact, that's really what the answer is. It turns out that it's a circle. There are actually some other ordered pairs that would make this work. For example, 4 comma 3 would work. Right? 16 plus 9 does equal 25. So 4, 3 is a solution. We could find 4 comma 3 right here. And so notice this point would also have to be along the graph. Now the graph, let's see if I can draw it okay here, would be a circle. Okay, I cannot draw a circle very well. But it turns out that the graph really is a circle centered at the origin, having radius 5. This was 4, 3. Okay, let's do one more example. Let's draw the graph of y equals x squared minus 2x minus 8. Now, this equation is nice because it just has y equals something that involves x. And when you just have y equals something that involves x, sometimes the easiest way to draw the graph is to do what's called a t-chart. Okay, and it's called a t because you see basically a t right here. Okay, and what you do with the t-chart is you pick different values for x and figure out what y would be for those values. Now I've just picked -3, -2, -1, 0, 1, 2, 3, 4, 5. You don't have to pick whole numbers. You could pick 3.7, for example, if you wanted to, but just pick a few values for x and then figure out what the y value would be. Now when x is -3, what is y? I found that y was 7. So I plugged in -3 everywhere I see an x here. So you have y equals -3 squared minus 2 times -3 minus 8. Now you have to be careful with all the negatives. -3 squared is +9, and -2 times -3 is +6, and then subtract 8. What that ends up being is 7, so I put 7 right there. Okay, so when x is -3, y is 7. Now you can also do it for all these other ones, and I already did, and I found the values right here. Now we can plot these ordered pairs. -3, 7 is going to be up here. Okay, -3, 7 is there. -2, 0 is right here. -1, -5 would be down here. 0, -8 would be here. 1, -9 would be down here. 2, -8, and so on. Okay, you plot these ordered pairs, and you can see 4, 0 and 5, 7. Okay, so all of these ordered pairs are going to have to be on the graph of our equation. What does our equation looks like? It turns out that it's what's called a parabola. Okay, so for this particular equation, the graph looks like this. Okay, and any equation that has the form y equals some equation, some expression that involves just x, you can make a t-chart and plot points. Now this is a little bit of a painful process because it's just time consuming, but for right now this method will work. Later on we'll learn for different types of functions, we'll learn how to graph the function without using a t-chart.